Hello once again, ladies and gentlemen, and welcome to our virtual classroom. Today, we are going to be going over lesson 19-3, rate of speed, which again is simply an application, of ratios and everything that we've been doing thus far in this class, rate of speed. Well, when we're talking about rate of speed, you need to understand that refers to that is the same thing as average speed. So anytime you're reading a word problem, they say rate of speed, average rate of speed. It is always referring to the distance traveled over a unit of time. Sorry, a distance traveled over a unit of time, meaning that the two units that I'm dealing with here are both distance and time. Again, that is distance and time. The distance traveled over a unit of time. And let me remind you that the word unit always refers to the number one. And so in essence, we're talking about the distance traveled over 1 unit of time. Think of something like how do we measure speed in a car? Wouldn't that be miles per hour? Miles per hour. Notice how we have our distance over time, the distance traveled over 1 hour. That's what miles per hour means. In fact, in all of these problems, you're always going to follow this pattern that you see right here. Distance in the numerator, that could be miles, kilometers, centimeters, meters, feet, yards. So that's distance over time in the denominator. It could be seconds, it could be hours, it could be days, it could be years. So some distance over some time. You might see that as miles per hour, as you see right here, again, distance over time. But really, in all of these problems, for example, look at this example. We have 500 miles in 8 hours. Notice how we have miles over hours. And so therefore, the 500 is in the numerator along with the miles, and the 8 is in the denominator along with the hours. And if we want to know the rate of speed, or the average speed, we want to know, well, how many miles are traveled in 1 hour, 1 unit of time? Well, obviously I divide by 8, and therefore that would give me 62.5 miles traveled in 1 hour. Meaning that if you were traveling at this rate, 62.5 miles in 1 hour, if you do that for 8 hours, you will travel 500 miles exactly. All right, well, with that in mind, let's go into our assignment here on Schoology. So we're beginning with number 2, which is here on OneNote. So number 2. Number 2 is asking, what is the average speed for a mousetrap car that covered 5 meters in 1.25 seconds? So we have a little cart that travels. We're looking for the average speed. So it's going to be some distance over some time. Distance over time. That traveled 5 meters, there's my distance, in 1.25 seconds, there's my time. Okay, so we have distance over time, and that's going to be 5 meters, right? So we have meters, specifically we have meters over seconds, I believe. 5 meters in 1.25 seconds. So 5 meters in 1.25 seconds. But again, I want to know the average speed. The distance traveled in 1 of time, so that's going to be in 1 second. Now, this should look very familiar, ladies and gentlemen. Okay, again, I have my ratio of meters per second, 5 meters in 1.25 seconds, but I want to know how many meters are being traveled in 1 second. Well, how do I get from 1.25 to 1? Remember, you can only multiply or divide. Well, as we did last week, anytime you have a number, if you divide that number by itself, so 1.25 divided by 1.25, that will give me 1. However, since I did that to the denominator, I'm going to divide the numerator by the same factor, 1.25. So we just need to do 5 divided into 1.25. Remember, the first number goes inside. Let us remember that when we're dividing, we do not like decimals on the outside. So I'm going to move this twice so that now it's 125. But that means that I must take this decimal on the 5 and move it 2 times, making this now a 500. So it's 500 divided by 125, which is exactly 4. Therefore, ladies and gentlemen, that means that this mousetrap car is traveling at 4 meters per second, or 4 meters in 1 second. Notice how I set this up. I began with my ratio in words, meters per second. Then I wrote down the ratio that was given to me, how many meters, 5 meters in how many seconds, in 1.25 seconds. And then I divided the denominator by itself to get 1, and I divided the numerator by the same factor so that I would then get my answer. That is the same pattern that we're following for each of these problems. And so we know that the answer to the first one is 4 meters per second. All right, look at number 4. Lucky for us, number 4 is actually given to us already right here. You don't even need to look at the textbook. If you look at the textbook, it's a little confusing. It's just telling you to go back to number 1 and do these problems right there. Sorry about that. So lucky for us, those problems are already right here. So same exact problem. We have 10 meters in 4.3 seconds. 4.30, same thing as 4.3, is how many meters in 1 second? All right, well, notice how we're working with meters and seconds again. That's my distance over time. We have 10 meters in 4.3 seconds, right? But we want to know meters per second, meters per 1 second. That's going to be my average speed. How do we get from there to there? Well, we know that we can divide 4.3 by itself so that it's a 1, meaning that if I divide 10 by 4.3, that's going to give you my answer. All right, first number goes inside, 10 divided by 4.3. Oh, that's a 5. That is not a 3. Same issue that I had in the previous problem. We do not like decimals on the outside, so I'm going to take that decimal and move it over. I had to move it over 1 time, meaning that I'm going to take the decimal here on the 10 and move it over 1 time as well, meaning that it's 100 divided by 43. All right, let's go ahead and divide 100 divided by 43. So 43 goes into 100. It doesn't go into the 1, doesn't go into 10, but it goes into 100 twice. That gives me 86. When I subtract these two, it gives me a remainder of 14. We already have a decimal, so let's just keep going. 43 goes into 143 times, because 43 times 3 is equal to 129. Let's subtract and we get a remainder of 11. Let's bring down a 0. Bring down a 0. 43 goes into 110 twice, I believe. That again is 86. And my remainder is 24. And let's bring down a 0. And 43 goes into 245 times, I believe. Now, ladies and gentlemen, if you keep going, it's going to go on forever. This will never stop. We're going to keep getting more and more decimal values. It's not even going to repeat. For all of these problems, we're rounding to the nearest hundredth. So I'm left with this number right here, 2.325, etc. But the nearest hundredth, meaning that I have to round 2 decimal places, so to the 2. Now, if I'm rounding to the hundredth, I'm going to look at the 2 and then look at the number to the right of it, which is a 5. Now, if it was a 4 or lower, the 2 would remain, but because it's a 5 or higher, that means that the 2 is going to become a 3, leaving me with 2.33. Notice that the 2 just went up to a 3. So 2.33 meters per second. So my answer here would be 2.33 meters per second. Notice that I rounded to 100. Do the same thing for any other problem here. If you have multiple decimals, round to the nearest hundredth, and that will be your answer. So hopefully, ladies and gentlemen, that is making sense. Hopefully that is making sense of how to do these problems. Yes, it's going to take quite a bit of division. I do not mind if you check your work with a calculator, just knowing that when we take a test, you won't be able to use one, but at least show me how you're setting this up. Show me how you're setting this up. One last thing that I want to cover is really number 5. So I'm going to go back to my textbook. And if I go to number 5, notice that I'm given this really interesting looking diagram where we have another little car. And this car is traveling from here to here. And that is a total of 15 feet. And notice how they did us a favor and they divided the 15 feet into 5 equal sections, each that is 3 feet long. So 3 feet, 3 feet, 3 feet, 3 feet, and 3 feet. And they're asking, well, what is the rate of speed? What is the unit speed or rate of speed? In other words, we need to know the speed per 1 second. So we know we're doing feet per second. We even know that we have 3 feet happening in every 0.5 seconds, but we want to know the speed of the car per second, so happening over 1 second. Well, we could solve this using proportions, or we can simply look at the chart here. Notice that every 0.5 seconds, which you should know 0.5 means half, it's going 3 feet. So 0.5, that is half, that is 3 feet, half a second, 3 feet. Another 0.5, now this is 1 full second. So in 1 second, it's going 6 feet. The answer is 6 feet per second. Yeah, because half a second, that's a full second, 3 feet, 3 feet, that's 6. So we have 6 feet per second. Notice how this would actually work out if I work it out over here. 0.5 to get to 1, you divide it by itself. 0.5 divided by 0.5, meaning I have to divide 3 by 0.5. If I work that out, 3 divided by 0.5, move the decimal over, that's 30 divided by 5, which is 6 or 6 feet per second. It works out either way, ladies and gentlemen. Don't let that one confuse you. All right, we've done a lot of these together. Hopefully you found this video helpful. Helpful enough for you to finish this on your own. And with that in mind, I will see you later.